All right. Example 4 is a really important question, and actually in some ways we should have done this first, because whenever it says to factor, you should always think about, is there a GCF, a greatest common factor? That's the very first step of factoring. No matter what question I give you, I don't care if it looks like this, if it's 5x squared plus 5x plus 10. You should all, if I said factor, anytime I say this word factor, please always think, is there a GCF? Because if not, you got the wrong answer if you didn't pull it out. Alright? So please star this. Anytime it says the word factor, write this down. Is there a GCF? Alright? So you don't realize how many people miss these questions on the test and quiz just because they don't think of doing this first. So please let that be you. Think of this first. Alright, so look at this. We got two terms, 1, 2. Is there a GCF? Because it said factor. Is there one? Yes, there is. 5x squared and 45. 5 and 45 have something in common. It is 5. So we factor out a 5. We've done this a little bit before. GCF is 5 between these two. Pull it out. So 5 times something gives me 5x squared. Well, it has to be x squared. 5 times x squared, 5x squared. Yes. Minus, because that's minus. 5 times something gives me 45. And that has to be 9. There you go. Alright, so right now it is factored, but it's not fully factored. Like this is a factor times this factor. Those two multiply to get this. But this can be factored more. X squared minus 9 is a difference of 2 squares. Remember that? So this becomes 5 still stays out front. X squared minus 9 factors into x minus 3 and x plus 3. There you go. This is fully factored. If you multiplied everything here together, you would get 5x squared minus 45. Okay? Letter B. 6q squared minus 14q plus 8. So it's a trinomial now. A lot of people will see this and they say, ooh, factor. Let me slide and divide. Or let me think about, okay, 6 is 2 and 3, 8 and 4, 2. No, no, no. Is there a GCF? Always first, no matter what. Alright, so think about 6, 14, and 8. Is there a GCF? Yes, there is. It's 2. So you pull out the 2. 2 times 3q squared minus 2 times what gives me 14q, 7q, plus 2 times what gives me 8, which is 4. Then I look at this and say, can this factor? It's ugly, yes, but can a factor? Well, slide and divide, or find factors of 3, find factors of 4, and see if they work. So let me 2. So factors of 3, that's easy. There's only 3q and 1q. So 3 and 1 make 3. So that's it. Factors of 4, there's 1 and 4 and 2 and 2. So, but we have to have a negative 7 in the end. So that's got to be minus. Got to be minus. So therefore, is it 1 and 4? Is it 4 and 1? Is it 2 and 2? Let's see if 2 and 2 works out. I think it does. So put 2. So negative 2 make positive 4. So I factored this. So remember what the little thing I taught you. Multiply the outside. That is what? Negative 6q. Multiply the inside. That's negative 2q. No, it didn't work, did it? So that didn't work. So if you add them up, they should be the middle term, which is negative 7q. So I actually have to try it again. So 2, 3q here, and 1q here, and it's not 2 and 2, so it has to be 1 and 4. I don't know which order. Let's find out. So let's put 1, 4. I can do it in my head here. No. So let's try 4 here and a 1 here, right? 4 and 1 make positive 4, right? And then let's check the outside, which is negative 3q. Check the inside, which is multiply those, negative 4q. Add those up, and look what you got, negative 7q, which is the middle term. So these are my factors. 1, 2, 3 factors. Multiply together to get this guy right here. So, know how to factor trinomials with a other than 1, and sometimes it keeps on factoring and sometimes it doesn't. So, Let's erase that, go to the next one. Oops, negative 5z plus 20z, 5 and 20 is 4, or no, 5. Okay, but since one of them is negative, I'm going to put a negative 5 instead. So negative 5, and also pay attention to the variable z squared and a z. There's two z's here, there's one z here, so there's one z in common in both of these. So negative 5z is my full GCF. Now negative 5z times something gives me negative 5z squared, which is just z. Now this is the tricky part. A lot of people see this plus and they want to put plus, but it's a negative out here, so if I put a negative here, negative times a negative, that gives me my positive. That's the common mistake. So negative 5z times what gives me positive 20, which is 4, not z, because it's already here. So this times this, check it real quick. This times this, negative 5z squared? Yes. This times negative 4. Positive 20z? Yes, correct. So this has to be your answer. There's no way you should miss these questions. Okay? Final answer factor. This times this. Last one, you could pull out 3. Okay? 3 times 4p squared minus 7p plus 1. 3 times 1 is 3. So multiply real quick. Do you get this? Yes. Now, I'll just tell you right now, we could try this, but it's not going to work. I already did it. So, this does not factor anymore. Does that mean your answer is not factorable? No. That just means this guy right here isn't factorable. The real question is this factorable? Yes, it is. It factors into one factor, two factors. This is your final answer. A lot of people miss this because this doesn't factor, and they say, oh, this isn't factorable. No, yeah, this isn't factorable, but this is, which factors into this. So this is your whole answer right there. So that's how you factor out mono.